Okay, so in this video, we're going to take a look at how to change the base of a logarithm. And we're going to find a formula for this. We're going to derive it. We're going to prove it. Let's start this going. So we'll start with a nice statement. What about this? B to the power of x is equal to a. And I suppose that could be interchanged with a logarithmic statement, which is log base b a is equal to x. What is it I raise b by to get a? X. Okay, so those two are fine. That's our starting point, right? So I think actually we will just write that out again. B to the x equals 8. But what we'll do some of our previous work on it. Let's take logarithms from both sides. Now, it doesn't matter what the base is, but let's just say log base c, right? And that's how we're going to get to our other bases later on. So we can certainly write that statement out that we've got the log of each side of this. Now, from there, what we can do, we can bring that x down with the third law of logarithms. So x log cb equals log ca. Then we can divide through by log base c of b. So we're going to have x is equal to log c of a, all divided by log base c of b. Okay, final step. Right back up here, we saw that x was log base b of a. Let's write that in. Log base b of a is equal to log base c of a, all divided by log base c of b. So there is our change of base rule, okay, that we can use again and again. Now, how does this work? So let me just show you in a quick example. We'll keep that there at the top. What if I had log base 7, 13? I don't know. Why would I want that? Who knows, right? But I wanted to change that into another logarithm, which is base 2. Well, it would be log base 2, 13 divided by log base 2 of 7. Right, just think it through. Take a look at the formula again. My A is 13, my B is 7, my C is 2, and I'm just swapping those numbers, right? Now, that isn't often used, but do you know what? I'm going to show you an example of an equation where it is really needed in a moment. So hopefully that will help you understand why this is important. So let's just take a look at this from a few different perspectives now, right? So first of all, we're thinking about log base 2 of 9, right? So how would I find out what that is? Just by saying, to start with, log base 2 of 9 is equal to x. Well, I guess I could write a statement from that, right? What is it I raised 2 by to get 9? X. So there's my equivalent exponential expression. From here, I could take logs of both sides. X log, do you know what, I'm jumping steps. Let's just leave it like that for a second. Equals to log of base 9. Then I can bring that x down. X log 2 equals log of 9. Now I can divide through by log 2. X is equal to log of 9 over log of 2. Okay, so that actually comes out at about 3.17, but that's how I could maybe do this. But what I could certainly do is use my new change of base formula, right? Because it just says turn it to base 10. Well, I can just jump straight into the formula, right? Let's go back to the formula, make sure we know it, right? Okay, it's right there. So I've got basically the fact that the B is the 2 and the A is the 9, right? And the C is the 10 because I want base 10. So log base 10 of 9 over log base 10 of 2 is the answer. Of course, it comes out at 3.17 again. And again, if I wanted it base e, right? Okay, that's the natural logarithm. So I could write it as ln of 9 over ln of 2. It still comes out at 3.17 every single time. So that's what's going on here. Now, we're just going to do one example of how this could be used, but it's a particularly challenging equation. See if you can do it yourself first if you'd like to. But we can't solve this until we have managed to write those logarithms with the same base. Now, I am going to choose to rewrite them both with a base of 2. I could have used 4, but I don't know. I could use anything. I think it would still work. But let's use 2. So how are we going to do this? So it's all about this one here, isn't it? Right? Okay. So, and you'll see why I've chosen 2 in just a moment. So if I want to use that change of base rule here and rewrite that with a base of 2, it's going to be log base 2x cubed over log base 2 of 4 plus log base 2. I think I'm going to write the root of x as x to the half is equal to 8, like that. Okay, now why was that useful? Well, log base 2 of 4 is a number. It's 2, isn't it, right? So I could certainly write this as a half log base 2x cubed. So I haven't put a 2 in front because log base 2, 4 is like a 2, but I'm dividing by it. So therefore, we've got like a half in front. Plus log base 2x to the half is equal to 8. Now I can try to bring these together. So first, I'm going to bring that half up top using the third law of logarithms. Log base 2x to the 3 over 2 plus log base 2x to the half equal to 8. Now I can use that first law of logarithms to bring those two pieces together. Log base 2x, well, it'll be x squared, won't it? Because I'm adding 3 over 2 to a half to get 2 is equal to 8. Okay, so from here, now I could try and write that 8 log base 2. That's going to work. I think I'll use a different method, though. I'm just going to try to create the exponential equivalent. So what is it I raised 2 by to get x squared? 8. That corresponds to 2 to the power of 8 equals x squared. If we square root both sides, we'll have 2 to the 4 is equal to x. Well, 2 to the 4 is a 16, isn't it? X is equal to 16 is our final answer. Okay, hopefully that made sense. You can see why we needed to change that base so we could bring those logarithms together using the laws that we're already comfortable with.